If you're a Reaction Plan Manager++ user, you understand how difficult it is to analyze hole patterns. You really need to evaluate all the holes in a pattern as a group to figure out how to adjust the manufacturing process. To perform this task, we use another application called Bolt Pattern Analysis. This application is designed specifically to analyze hole patterns. Using RPM++, you can launch and build a bolt pattern analysis solution using data collected by RPM++. There is a video called Reaction Plan Manager++ Analyzing Hole Patterns that will demonstrate how the applications work together. In this video, I will show you how to set up RPM++ to analyze hole patterns. Let's start by running a few simulations to see what we're shooting for. I'm going to use this RPM Training CMM to generate to simulate measuring a part on some sort of CMM or other inspection equipment. Here I'm going to run the RPM++ Simple Hole Location simulation. RPM does its job, loads the appropriate solution, does an analysis, and gives you a report. Here I can see for machine A I've got some issues with this hole pattern, and you'll notice here I've got the bolt pattern analysis button illuminated here. I can click on this button and it will start the bolt pattern analysis software and build a solution inside the bolt pattern analysis software using the data collected from RPM++. This is what we're shooting for. We want to set up RPM++ so the operator can click on this button and it builds this solution for him automatically. I'm going to select another simulation and run it. Let's pick the RPM++ basics. Let's run that simulation. Here you can see I've got another button here for the bolt pattern analysis software. If I click on this button, it'll bring up the bolt pattern analysis software. Here it's configured a little differently. I can see I've got machine A, machine B, machine C, and machine 3. And of course I can click on the appropriate machines to see what's going on with each one of them. If I pick a simulation that doesn't have that configured into the software, the bolt pattern analysis button will not be selectable. Let's try this simulation and see what happens. Here you can see the bolt pattern analysis button isn't available here because this particular solution is not configured to analyze bolt holes. To show you how to configure a solution, Reaction Plan Manager solution, to build a bolt pattern analysis solution, I'm going to develop a Reaction Plan Manager++ solution from scratch. I'm going to assume you have the basic knowledge in developing reaction plans. Alright, I'm going to pick a simulation called Write New Solution. I know there's no solution associated with this particular simulation, so I'm going to use the Auto Solution Builder inside Reaction Plan Manager to build the basic structure for this particular simulation. So if I click on the Inspect button, you'll see here the Reaction Plan Manager went through the data and created the dimensional items for the data that was available. We use the Auto Solution Builder to do that, and you can see that at the bottom. It says a solution to process RPM++ write new solution.csv cannot be found and was automatically built. If you look at the data, you'll see 1x, 1y, 1 true position, 2x, 2y, 2 true position, 3x, 3y, etc., etc., etc. I know that this data represents a 6 bolt hole pattern. The linear locations and the true position are reported, as well as the diameters here at the bottom. So when you're using the software, the bolt pattern analysis software needs the linear locations of the holes as well as the true positions. It doesn't necessarily need the diameters, that's optional, but at minimum you need the linear locations and the true positions. Let's go to the edit mode and start working on this solution. Well, right off the bat, I'm going to use the quick dimension edit and make some changes to the dimensional items. To start with, I'm going to get rid of the display process reset button when a rule is broken. We don't need to see that. I don't care about that, so I'm going to disable that. And we really don't need to see the linear locations. We need the linear locations of the holes, but we really don't need to see it in the end, the Reaction Plane Manager report. So I'm going to mark each one of the linear locations as a auxiliary dimension. For those of you who don't know, if you mark a dimensional item as auxiliary, that dimensional item is there, it's just not visible when you're in the view mode. So I'm going to apply the changes, say OK. You'll notice that the linear locations are grayed out. That's to let you know that they're marked as auxiliary. Next thing I'm going to do is I'm going to put all the holes that are in this pattern into a group. Click all of them, insert a new group, say OK. Then I'll do a quick group edit. Change the name of this group to something meaningful. Give it a message if no rules are violated. Turn on the sequential evaluation, and I'll display a button if an operator makes an adjustment. I'm not going to worry about pictures or the detailed view for this demonstration. Okay, now I've got my group set and my dimensional items set as well. So now I'm ready to start working on the bolt pattern analysis stuff. When the operator clicks on the bolt pattern analysis button, which is displayed here, what really happens is Reaction Plane Manager++ hands off a template to the bolt pattern analysis software. The template describes the patterns and which dimensional items to dissect to build holes 1, holes 2, holes 3, etc. So if you think about it, I know that in this particular case where I've got a 1x, and a 1y, and a 1 true position, these three dimensional items equates to a hole. 2x, 2y, 2 true position, this is a second hole. 3x, 3y, 3 true position, that's a third hole. So somewhere you have to describe which dimensional items equates to holes 1, holes 2, holes 3, etc. So to build a template, you click on the BP template button here. And what that will do is it'll bring up a window which you can use to build your template. You'll notice at the top I've got an add pattern button, add new feature hole /pin, OK, cancel. And below that I've got selected dimensional items and the desired number of parts. when you set up a template, first thing you really got to do is think about how many parts you want to use in the analysis. This can vary depending upon how you want to evaluate the process. You could use all available parts. You can ask the operator, in other words, display a window to the operator, and then he has to tell how many parts to use, or you can use a fixed number. Now obviously if I've got 5 machines, each machine will have a varied number of parts available for each machine. So it figures out the what it can and what it cannot use with regards to building the solution based upon the number of parts that are available. I mean, clearly if I've got this set to fixed number and I've got this set to 100 and I only have 5 parts available for a particular plan, it's going to use 5 parts instead of 100. Okay. I'm going to leave this set to ask operator. Well, I'm going to build one pattern, and you can see how it works. So if I click on the Add Pattern button, you'll notice it puts a pattern here. You can give it a name. And there are some settings you can set that are used by the bulk pattern analysis software to figure out how to set up the bulk pattern. I can display the origin if I want. I can display the part axes. I can display the world axes. I can set the scale factor for viewing the true position zones. I can set the percent of tolerance. Here I've got it set to 80%. I can modify the coordinate system. Sometimes you may need to adjust the coordinate system to make it match the manufacturing process. So you'll define and set these values here. And when you're done, all you have to do then is add new feature hole/pins. There are a couple of ways you can add new features. The easiest way is if I click on the X, then click on the Y, then click on the true position, and then click on Add New Feature. It will add the feature. It's an inside diameter. The X dimension is 1X. The Y dimension is 1Y. The true position dimension is 1TP. Since I didn't pick a diameter dimension, that's optional. There's nothing displayed there. So you have to follow that sequence. The X, the dimension that represents the X, the dimension that represents the Y, the dimension that represents the true position, and the dimension that represents the diameter. And then here you can give it a name here if you want. You can change the name. And that's really all there is to adding a feature. If I want, I could just click on Add Feature. Well, since that was already selected, it used the 1X again. I'm going to make this hole 2. And then I'm going to click on the X dimension, and then I can click on the corresponding dimension that I want to be X. Click on Y, and then click on the corresponding dimension that I want to represent Y, and then the true position, and then the diameter if you want. That's another way of doing it. Personally, I like to just click them all, add new feature, go to the next one, add new feature, go to the next one, add new feature, go to the next one, add new feature, and then I'll go back and change the names accordingly. Hole 3, hole 4, hole 5, and hole 6. If I wanted to add another pattern, I just simply click on Add Pattern. It adds another one at the end. Give this another name. Answer the questions accordingly. And then add some more features to it. This time I'm going to add just 2 holes to this one. Let's make it hole 2 and hole 5. I mean, that's all there is to it. It's really pretty simple. You can move them around. You can delete dimensional items. You can delete features and redo them. I can delete patterns. I can move them up and down to get them in the appropriate order to make it conducive, make it pleasant for you to look at when you actually pull up the bolt pattern analysis software. I don't know if you noticed, but when I change dimension items, this list will change to depict the dimensional items that are needed to fill out that information. And you also don't have to worry about the order in which the dimensional items are listed. It will remember which one it is no matter what the order is. That's really all there is to setting up a template, a bolt pattern analysis template. When you're done, you say OK, and now you'll notice the bolt pattern analysis button is available. That's because there is a template associated with this solution. So let's go ahead and hit the bolt pattern analysis button and see what happens. The bolt pattern analysis software starts. This time I'm prompted for how many parts. Well, there's only one part available, so it's only going to allow us to choose one part. So if I click on OK, here you'll notice here's my 6-hole pattern. Here's my 2-hole pattern. You notice there's 2 rings around all the holes in the 6-hole pattern except for one. That's because this particular hole, I did not identify the diameter, so it didn't calculate the bonus tolerances. The other holes, I did include the diameter, so it calculated the maximum material condition for those holes. That's all there really is to it. It's pretty simple. And once you're done, this is ready to go. There are a couple other things I'd like to change in this solution. One of them is I like to hide the severity levels so that I'm only looking at the warning and critical severity levels. And I didn't set up my data collector to filter the data. So let's go ahead and filter that data based upon some criteria. Let's use I think there's a machine. Yeah, there's a machine in this data set. So we're going to filter the data by machine. Let's save this solution. And I'm going to delete this reaction plan because since I've got the filter set, I really don't want that blank reaction plan. So now if we go to the view mode and we inspect a part, machine A, we've got some issues there. Oh, something else I'd want to change as well. It's telling me to make an adjustment here. It would be better to just tell the user or the operator to reference the bolt pattern analysis software for any sort of adjustment for the true position. So let's go ahead and change the last run reaction to say use bolt pattern analysis to calculate machine. Now to get machine adjustments. We'll copy that and put it in the out of tolerance one as well. I mean, I could set all this up and make it, instead of looking at one part, maybe look at the last 5 parts. You know how to do all that stuff, so I'm not gonna go over that. Go back to view. That's better. Alright, let's go ahead and run some parts. I'm going to inspect let's change this to 1 second intervals. I'm going to inspect I don't know, let's do 5 parts for A. I think that's 5. And then for machine, I'll change that from machine A to machine B. We'll inspect 2 parts. And we'll inspect 1 part for machine C. Alright, so now if I hit the bolt pattern analysis button, it's going to start the bolt pattern analysis software. You'll notice I've got 7 parts displayed here because machine A, I know there's 7 parts. Machine B has fewer parts and machine C has only 1 part. If I pick 5 parts, let's say, it started the bolt pattern analysis and it tried to use 5 parts for each machine, but you'll notice machine B only has 2 parts, machine A has 5 parts, machine C only has 1 part. So it's going to use, if there's not enough parts to satisfy the number, it'll use what it has available to it. So here you notice we've got 6 patterns, 2 for machine A, 2 for machine B, 2 for machine C, my 6-hole pattern, my 2-hole pattern. Now I can go in here and do my best fits to figure out what my adjustments are. So you can see it's pretty straightforward and pretty simple. Once you're done, you know, you're ready to put it into production. That's really all there is to configuring a solution to set up the bolt pattern analysis software. To learn more about these software packages, visit www.beckerqualitysolutions.com and click on the help video links at the bottom of the web page.